Okay, so on problem 7, this is the answers that were in the back. If you check your answers, they're just real simple statements of each one of those: a hypothesis, proposal of possible explanation. B, an experiment or procedure that tests the validity of A, or hypothesis. C, theory is a hypothesis that has been validated many times by different scientists. And then D, an observation is a description or measurement of that natural phenomena that you're going through and doing. So that would be your answers for 7 that you'd have. We're going to look at the actual questions. I know you guys might have them in front of you there, but we'll look at the actual questions that you had to do on the other ones, and then we'll talk about your answers. So, 8, as you go down through that, formulate a possible explanation for your experimental results. What would that be? Hypothesis. B, make notes about nature. Observations. Design an experimental plan. Experiment, and then state generalized summary of your experimental results. Conclusion. Questions. Okay? We'll go to the next one. I think I did you guys do 10 through 12. Yeah. Okay, so on this one, Lucia wants to develop a process for dyeing shirts so the color will not fade when the shirt is washed. She proceeds with the following activities. Lucia notices that the dye in a design fades when the shirt is washed. Observation. Okay? That's the observation she made to kind of get to this point where she doesn't want it to fade. So Lucia decides to dye, needs something to help it combine with the fabric. What's that? Hypothesis. Okay. Could it be a conclusion or not? I mean.
Yeah. Like came to the conclusion that she wanted to.
Well, she had made observations that, and then if that was part of her experiment or whatever, washing multiple times, then it could be. I mean, depending upon frame of reference, probably be more of an observation than anything. C, she places a spot of dye on each of the 4 shirts. She places them in separate water, salt water, vinegar, and baking soda. What's that? Experiment. Then she takes them out after an hour and wash with detergent. Part of the experiment still. And then Lucia thinks that the vinegar binds with the dye so it does not fade when the shirt is washed. What do you think of that? Conclusion? And I would not have a problem with that. It is a conclusion, but she could continue just to make sure she could use different percentages of vinegar, different strengths of it, and then continue on. So it could help build upon another hypothesis and say, well, this vinegar binds better than this one, and she could kind of go on, but it's probably more of a conclusion than anything. All right. We got a person that gets sick or has stomach cramps after he drinks regular milk. So what's that? A observation. He thinks he's lactose intolerant. That would be a hypothesis. Can he test it? Well, what he does to test it is he drinks lactose-free milk and he does not have stomach cramps. So that would be the experiment that he's doing. And then D, drinks regular milk in which he's added lactase, an enzyme that breaks down lactose, and has no stomach cramps. What do you think on that? Experiment. So he did 2 different experiments in which to test it. Okay? And then, last one, Sally thinks she's allergic to shrimp. You think that would be an observation? It could be an observation if it said something earlier that she started breaking out when she had shrimp. But it doesn't really give us any information. So that would be more of a hypothesis. Can she test it? She goes ahead and eats some shrimp salad and broke out. So that would be what? Experiment?
This was yesterday. So would it be an observation if it was yesterday?
Oh, yesterday. Good one. Not okay. It really depends upon the present tense, what she's doing. So it could be an observation, or it could be that she just did it. You know, it all goes. You're not getting a lot of information about this, but I could accept that. Okay. Today, Sally had some soup that contained shrimp, but she did not break out in hives. It could be an experiment. Okay. And then D, Sally realizes she does not have an allergy to shrimp. Conclusion. Okay. And then that could work into another hypothesis to where, okay, she did these two things. What? You know, what caused it? Is it a combination? Is it a different type of shrimp? I don't know. So she would probably want to take steps further and let's do that. So, okay, good discussion on that. At this point, if you have your book, we are going to take a look at scientific notation. It is section 1.5. We will deal with scientific notation in here a lot, and you can actually plug it in your calculator if you know how your calculator works with scientific notation. Pretty much all your calculators can be expressed in scientific notation. We'll show you that later. We're going to not show you that now because all of these problems can be done without a calculator that you have to do today, dealing with scientific notation, adding, subtracting, multiplying, dividing. So the very first thing you'd have to do is take a normal number and change it into something that's scientific notation. For example, this 2400 could be written in another form, which we call scientific notation, by taking the decimal and moving it to the point to where we have just one digit that's to the left of that decimal. You can only have one digit to the left. Okay? You can't have 0 digits or 2 digits. It always proceeds to where you just have one digit to the left to make it correct. So that would be correct scientific notation. The times 10 would mean that you'd multiply it by itself 3 times. 10 times 10 times 10, which is 1,000. Okay, so that would be times 1,000. This is 1,000, which would get this number back, 2,400 if you had to do it. I don't indicate if you move it left, it's positive exponent. If you move it right, it's a negative exponent because I get those mixed up. Okay? And I know if I do, or have in the past, you guys will, because you'll go, well, what's the rule? You move it left? Oh, no. I don't remember. So what I do is I say if it's a big number, it's just a positive exponent. You know, if it's a big number that you're making smaller, you're just going to create a situation where it's a positive exponent. And if it's a small number and we move it, then it's negative. Okay? If it's smaller than 1, it's going to be a negative exponent. So we're going to go ahead and practice that. They do show you examples how to do that. So we're going to go ahead and practice that with these examples here. I probably got about 10 examples where we'll go through not just moving the decimal, but just doing some examples. Include the units when you do these because we want to get good practice of always including units when we have answers, okay? And for some of you, it's been a while since you did scientific notation, but you'll pick it up in a hurry. I used to do used to show numbers where I'd show, it'd have a separation of the comma every so many numbers. Why do you think I choose not to show that, or books don't show that? Any ideas? What does this represent in some languages? A decimal. So people, like in Spanish, that would be 17.9 to them. So that's why I don't include that. And there's a little separation all the time so that when you count them, it's easier to count by threes and do that up to a certain point. So this first one, we're going to move it to the right. How many places? 7. So it becomes 9.6 times 10. And then if it's a small number, what kind of exponent does it have? Negative. So negative 7. And then in this one, we move to the left 4 places. So it becomes 1.79 times 10 to the 4th. Okay. Any questions on that? Movement becomes your exponent, how many times you move it. Small numbers, a negative exponent. Larger numbers, positive exponents. So let's have you just do 2 on your own real quick, and we'll do the answers. Now, the reason to move the decimals, sometimes when you do it to a point where it helps you do some calculations later on. Sometimes it's just simplifying the numbers so you don't have so many zeros, or you can plug it in your calculator in a certain way. So most times we're not going to show numbers like 3 and 4. We're just not going to show those. They'll be shown in scientific notation. On the test, most students do a really good job. The only thing that they mess up on is they have the wrong exponent. Where it's supposed to be positive, they have negative, where it's negative. So then they miss all those. I have to check them. I mean, they just get them all wrong. And so I guess it's one of those things, you get them all right or all wrong, but if you can do enough of them, it's not that big of a deal. You can figure it out. So number 3 would be 5.49 times 10 to the negative 4. And then number 4 is 1.1 times 10 to the 9. Now, when we get into what they call this thing significant digits, which for some students, it's hard for them to wrap their head around significant digits and what they are, and hopefully we'll go through it in a way that you guys can understand it better. Significant digits are actually numbers that were actually measured. They were actually measured numbers. So like on this one, how do we know that these zeros are actually measured, or they're just rounded to the nearest, 100 million? Okay? There's ways you can tell. And if you express it in scientific notation, the number of digits expressed in scientific notation always tells you how many significant digits you have. So when we get to that point of significant digits, scientific notation, if it's expressed in scientific notation, all the digits that are shown in front of the multiplication sign are counted as part of the measurement. They're significant. Okay? All right. And it's just a tool they have for later on when you have to express your answers and experiments correctly with correct number of significant digits. That's kind of what we'll look at. Now, there's rules for multiplying and dividing, adding and subtracting exponents. The rule for multiplying, what do you do with your exponents when you multiply numbers that have exponents in them? You add them. So this now, I should have made this larger. I thought when I copied it, it would be larger. So I'm going to go ahead and re-show those so you can see what those numbers are. So the first 2 numbers will be multiplied. So 2 times 3 is 6 times 10, and then the exponents we add. So minus 8 plus 5 is negative 3, right? So that answer would be 6 times 10 to the minus third. So exponents that you multiply, you add. And then the number that's out in front, or coefficient out in front, you multiply. So go ahead and do 7. Problem with 7, you got to do one extra step. You have to get it back to where you have one digit to the left of the decimal. Let's see if you can do it. See if you can come up with the right answer. So 4 times 10 to the third multiplied by 3 times 10 to the minus 8. Now the units for this one should have been meters squared. Meters times meters is like area in the meter squared. So go ahead and do number 7. Is that what you originally got, and then you have to change it, right? So this is to the minus fifth. We're going to go ahead and take where the decimal's at. We're going to move it over. So it becomes 1.2. We made a bigger number smaller. So do you add 1 or do you add a negative 1? You add 1. Remember, when you move it to make a bigger number smaller, what's the exponent's sign? It's positive, right? So I'm going to take that negative 5, I'm going to add a positive to it, 1. So it becomes a negative 4. Does that make sense? So here's the deal. Students will make that a minus 6 a lot of times and get it wrong. It's no different than what we did up here. We moved this, we added 4. Okay? If we move it the other way, we add a negative 1. Okay? We make a smaller number larger. So it's not any different by doing that. You're going to either add an exponent, if you make a bigger number smaller, or you're going to add a negative exponent, okay, to that original exponent. Okay? Now, dividing, what do? You subtract. So do 8 and 9. So I'm going to rewrite those so you guys can see them in the back. Okay. So the first numbers you divide out, get an answer, and then when you take the exponent, you would take the first number minus, first exponent minus the second exponent. I wrote that one wrong, didn't I? It should be to the minus 4. I'm sorry. Minus 4. So the first one is 4 divided by 2 is 2 times 10 to the, so minus 4 minus 5 is negative 9. Minus 4 minus 5. Next one, 4 divided by 8 is 0.5, right? It's half. So 0.5 times 10. And so we got 5 minus a minus 8. So we got 5 minus a minus 8. So that's like plus. So that'd be 13. So it'd be 0.5 to the 13th. Go ahead and tell me what the exponent would be when I change it into where I got one digit to the left. Unless you've already done that. So we move it. It becomes 5 times 10. So if I move it right, the exponent's going to be a negative 1. If I just, without this number, is the exponent going to be a negative 1 or 1? Negative 1. So I add a negative 1 to that. So the answer is what? 12. If you did 14, no. That would be if it was 50 times 10 to the 13. Then it would be 14. So just, when you do it, just, maybe cover up that number and go, okay, I'm going to move it 1. That becomes a negative 1 exponent. I'm going to add a negative 1 to that. Or if it's 50, you move it. Okay, I'm going to add 1. It'll be times 10 to the first. So then I'll add 1 to that. All right. And then the last one, you guys get to practice all of these. If you add and subtract. So on this one, we're subtracting then. The exponents have to be the same when you subtract. If they're not the same, then you can't subtract. You have to get them the same. So on this first one, the exponents are the same, right? So all I do is take the first number and I go ahead and find the sum of what that's going to be. So 7.5 minus 1.5 is what? 6. And then the exponent is not, it's not a minus 8. Okay, we're not multiplying, it is minus 4, the same. So the exponent won't ever change. It'll be whatever you have. So on 13, they are different. It does not matter which one you change into the other. You have to change one into the other exponent. You have to make the 5 a 6. You're going to make this become a 6 and then move this decimal to do that. Which way would you move that to make it a 6? Left or right? Left. So if I move it left, that will add an exponent to that. That would be 10 to the 6. Or, okay, if you prefer to make this one the same, you would move this to the right, and then that would be to the 5th, right? Either way's right. Either way's okay, but then you have to get it back in the normal form. So make sure. So go ahead, decide what you want to do, and let's see what you get for an answer. So let's say that we decide to change this one to this exponent. It would become 0.2 times 10 to the 6. So it would be 7.3 times 10 to the 6 plus 0.2. So my answer is what? 7.5 times 10 to the 6, correct? Oh, we're subtracting, duh. Okay, so it would be 7.1.
Yeah.
Now, if you decided to go, I don't like that one, I want to do the one that's a 6, that becomes 73 times 10 to the 5th. And then we would subtract 2 times 10 to the 5th. Our answer is what? 71 times 10 to the 5th. And then I need to move it 1, so it becomes 7.1 times 10 to the 6th. Same thing. So it really doesn't matter which one that you decide. They have to be, if you add and subtract, they have to be the same. So this skill that you guys are going to practice and learn to become more proficient at will help you when it comes to dealing with these big and small numbers that you don't want to have to plug in your calculator all the time. Okay? You might plug in the first number when you divide or multiply and that on a calculator, but the rest of it's going to be pretty easy because it's based upon those rules at hand. All right.